I'm going to start you with an easy one. A simple little warm-up activity here. These are sample kinematics questions. So we're going to be using some of the formulas and whatnot that we've seen so far. So you should park your phone and be ready to pay attention. So we've got an object starting in a position of -6. It ends up at a position of +10. Calculate its displacement during the trip. So pretty simple. We are looking for delta D. And the formula for delta D is final position minus initial position, right? Mm-hmm. Where you ended up, subtract where you started. Are you going to be discussing bagpipes now, or?
Not like Tony.
Okay. I would like to discuss this. All right. So what is the final position? It starts at a position of -6, so that is my initial, and that makes the other one have to be the final. So it's going to be, what's my final? Notice how I've written the formula, and then right underneath I'm going to substitute. So the final position is 10, and the initial position is?
Minus -6.
Minus -6. And I specifically chose -6 to start so that you would see subtract -6. Giving us, of course, a displacement of +16. Okay, here's number 2. An object moves from a position of +10 to a position of -13 in 7 seconds. This time I've got some time involved. We need to find the displacement, and we need to find the average velocity. So, let's write our formula again. Delta D is final minus initial, and let's write it so that people can read it. We did number 1 already. I was doing number 1. The final position is -13. The initial position is +10, so it's subtract 10. I have a displacement then of -23. Hopefully that isn't too baffling for you. Now, average velocity, we're going to use V bar is equal to D over T. Hello, Mr. Muffenmeyer. So it's going to be what? 23? I think it's -23. Is that what you meant? 7 seconds. So -23 divided by 7. Logan stole my calculator. Should we just say -3.3?
Yes.
Meters per second. Do you think I would be looking at the negative sign?
Yeah.
Yeah, that would be an error if you didn't include that. Okay, so probably 2 marks for that. Show your formula. It's real important. Okay, it's a good habit to get into. I know it's a little tedious sometimes, but as the questions get bigger and bigger and bigger, it helps you sort of process things. So please, I encourage you to do it. All right, number 3 looks pretty easy. I only see 2 numbers, so that's a good sign. Find the time required to travel 150 kilometers at a rate of 80 kilometers an hour. I'm solving for time. I've got my distance. That's my velocity. V bar is equal to D over T. Now I've got V bar, average velocity. If it's traveling at a rate of 80 kilometers per hour, that sort of implies that it's a constant 80, which means my average is 80, right? So that's going to be 80 is equal to 150 over T. How do you solve when the unknown is on the bottom?
Cross multiply.
Sort of cross multiply, switch positions. T is 150 over 80. T is equal to 150 over 80. What is it, Ben? Can we say 1.9?
Does it matter though?
1.9 hours. I think now you've probably got enough ability that you could probably try number 4 on your own. Okay? And I was successful with that with this morning's class, so we're going to try that again. So what I would suggest that you do is draw a line down the middle of this number 4 space. Okay? And you do your answer over here. It's good practice in sort of organizing yourself because there should be just enough room there. You do your answer here, and then I'm going to do my answer over here, and if you need to, well, then you can refer to the real answer, but I'm guessing you're all going to get it right anyways. You try number 4 on the left-hand side. Alrighty, so a ball rolls down a hill with uniform acceleration. It starts from rest, so right away that tells me that my initial velocity is 0. It rolls 28 meters, my d is 28, and my time is 4 seconds. Find the average velocity, the final velocity, and the acceleration. It may help you to jot these things down. It helps some kids to sort of realize what they've got and what formulas they need to use. So we are asked to find the average velocity. Average velocity is v bar is equal to d over t. Okay? So, Logan Gan, what d do I use? 28, exactly. And the time, of course, would be? 4 seconds. 28 divided by 4?
7.
7 meters per second is my average speed.
So you had to divide by 2, and that's your average velocity.
You would average that when you're adding when you're finding the average of two different things, you do that.
Isn't that your average?
That's my average velocity. Did I say speed?
Yeah.
Average velocity. Okay? Now, I started at 0, right? I started at 0. I averaged 7, so my final velocity is going to have to be?
14.
14. Now, how do I actually write that sort of in a formula kind of thing? Okay? Brad has a question.
Is it 28 times 4 times 0.5? Is your linear displacement? That would...
Yeah?
No, it would have to be just 28.
No, yeah, no, you're... No.
It'd be 5 plus initial divided by 2.
There you go, Connor. Connor's got it right. The because I'm looking for the final velocity, I'm trying to solve for VF. I have VI, I have V bar, I don't have VF. V bar is the average of two things, is VI plus VF all over 2, right? I'm averaging those two things.
That's what you want.
V bar is equal to VI plus VF over 2. It's the formula for averaging two things. What two things? VI and VF. Do I know the average? Yeah, it's 7. Do I know the initial? Yeah, it's 0. Divide by 2. How do I get rid of the divide by 2?
Multiply by 2.
Multiply both sides by 2. Right? 2 times 7 is equal to V 0 plus VF. Or in other words, VF is equal to 14, which is what I heard someone say 30 seconds ago. Okay? Now, the danger with just taking this times 2, and we'll get back, well, I'm going to come back to that in a second, okay? All right, so I've got my average, I've got my final, now I need to find my acceleration. Now my acceleration is delta V over delta T. I have my time, my change in time, and the whole thing happened in 4 seconds. Do I have my change in velocity? Miguel, I'll put the phone away. Do I have my delta V? What is it? How do you know? That says VF equals 14.
What's the change?
Because the velocity from the initial to the
It's 14, exactly. It went from 0 to 14, okay?
Got it wrong.
So my delta V is equal to 14
Divided by 4.
divided by 4 is 3.5 meters per second squared.
So, wait. Isn't it average velocity though?
no.
A is delta V. Acceleration is change in velocity over change in time. And that's a good point, Miguel, because lots of people will try. If I didn't ask this step, if I just said find the average velocity and find the acceleration, a lot of people are going to take this 7 and put it in there, and that is wrong. Why is it wrong? This is V bar is 7. This is delta V. V bar, excuse me, is not equal to delta V. They are not the same thing. One is the average, one is the change.
VF equal to delta V?
Almost.
Oh.
Almost. All right. Once again, a really good idea is to write out what you know. An object has an initial velocity of 1 meter per second. VI is 1. It reaches a final velocity of 12 meters per second. VF equals 12. 3 seconds later, Time is 3. Find the acceleration. Okay, find the acceleration. Acceleration is change in velocity over change in time. Do I have the change in time?
Yes.
It's 3. Do I have the change in velocity?
No.
Not exactly. I've got VI and VF. Now, back here, we said that delta V was equal to 14 because it went from 0 to 14. The VF was equal to the delta V. But that is only true
When the VI is 0.
when the VI is 0. Exactly, right? And I'm just going to make a little note of this here. Delta V is equal to VF only when the initial velocity is 0. And that's not always true, so it's a dangerous sort of rule to follow. Okay? Don't always assume that the change in velocity is equal to the final velocity, because it depends on what the starting velocity is. So in other words, I got to find my delta V first. Well, fortunately, that's relatively easy to do.
Final minus initial.
Final minus initial, exactly, Kish. What's the final velocity? 12. Final velocity, 12, right there. What's the initial? 1. Does it not make sense that the change in velocity is 11? You went from 1 to 12? Right? How much did the velocity change? It went from 1 to 12. It changed by 11. Now I take that delta V and put it where? Over there. A equals 11 over, my time is 3, my acceleration then is 11 divided by 3, 3.67 meters per second.
Did you have to put square on it?
Yeah, well, 3.7, sure.
I got it right, Kenny.
I don't put 3.6, 3.7 if you're going to round to 1 decimal place. Right. I'll take that. Alrighty, don't start talking yet. Don't. I need about 1 more minute. Okay, so what you have now is, you have a lot of time. Okay, I'm going to put the lights back on, so shield your eyes. You have a whole sheet of problems here on the back. There are answers on the back. You can check your own work. There's more problems coming tomorrow. You have the rest of this period. You have tomorrow and you have Thursday to get yourself ready for this test. Do not waste this time.
Yeah, wait 6 months.
Okay? Remember, you have a cheat sheet ready for Friday. Get everything all squared away by Thursday, the end of the period. Okay? Any questions? Friday.